Convection. Convection is the mode of heat transfer is met within situations where energy is transferred as heat to a flowing fluid at the surface over which the flow occurs. This mode is basically conduction in a very thin fluid layer at the surface and then mixing caused by the flow. The energy transfer is by combined molecular diffusion and bulk flow. The heat flow is independent of the properties of the material of the surface and depends only on the fluid properties. However, the shape and nature of the surface will influence the flow and hence the heat transfer. Convection is not a pure mode as conduction or radiation and hence involves several parameters. If the flow is caused by external means like a fan or pump, then the mode is known as forced convection. If the flow is due to the buoyant forces caused by temperature difference in the fluid body, then the mode is known as free or natural convection. In most applications, heat is transferred from one fluid to another separated by a solid surface. So heat is transferred from the hot fluid to the surface and then from the surface to the cold fluid by convection. In the design process, this convection mode becomes the most important one in the point of view of application. The rate equation is due to Newton, who clubbed all the parameters into a single one called convective heat transfer coefficient H. In the stable continental area, surface heat flow systematically decreases with the age of the surface rocks. Later, we will see that this effect can be attributed to the decrease in the crustal concentrations of the heat producing isotopes due to progressive aeration. Convection is the mode of energy transfer between a solid surface and the adjacent liquid or gas that is in motion, and it involves the combined effects of conduction and fluid motion. The faster the fluid motion, the greater the convection heat transfer. In the absence of any bulk fluid motion, heat transfer between a solid surface and the adjacent fluid flow is by pure conduction. The presence of bulk motion of the fluid enhances the heat transfer between the solid surface and the fluid, but it also complicates the determination of heat transfer rates. Consider the cooling of a hot block by blowing cool air over its top surface. Energy is first transferred to the air layer adjacent to the block by conduction. This energy is then carried away from the surface by convection, that is, by the combined effects of conduction within the air, that is due to random motion of air molecules, and the bulk or macroscopic motion of the air that removes the heated air near the surface and replaces it by the cooled air. Convection is called forced convection if the fluid is forced to flow over the surface by external means such as a fan or pump or the wind. In contrast, convection is called natural or free convection if the fluid motion is caused by buoyancy forces that are induced by density differences due to the variation of temperature in the fluid. For example, in the absence of a fan, heat transfer from the surface of the hot block will be by natural convection. The air near the surface and the fall of the cooler air to fill its place. Heat transfer between the block and the surrounding air will be by conduction if the temperature difference between the air and the block is not large enough to overcome the resistance of air to movement and thus to initiate natural convection currents. Heat transfer processes that involve change of phase of a fluid are also considered to be convection because of the fluid motion induced during the process, such as the rise of the vapor bubbles during boiling or the fall of the liquid droplets during condensation. Despite the complexity of convection, the rate of convection heat transfer is observed to be proportional to the temperature difference and is conveniently expressed by Newton's law of cooling as Q convection equal to HA into Ts minus T infinity. where H is the convection heat transfer coefficient in watt per meter square and A is the surface area through which convection heat transfer takes place.